quickly, I'll walk through what is Big Data Hadoop for people who don't know, and that too quickly I'll be doing because our webinar is basically based on Apache Spark. So how big data came into picture? This picture actually gives you a view of how big data actually came into picture. So previously you had only calls and text messages you could do with your mobile phone. That was all that you could do. But now you have so many applications, apps on your mobile phone for music, sports, games, social media, or you do so many tweets and so many messages, all those chattings. So all that data is actually growing, right? Because of that data is growing because you are having different applications. So this, because the data is growing, so this term, the big data has come into picture. So what is big data? It's actually extreme large set of data. So if I give you example, you go to a shop market and you buy a toothpaste every 2 months, right? So the shop market notes down, like Big Bazaar, it notes down, okay, this person is buying toothpaste every 2 months, and it notes down that trend, this pattern of the customer, and then they can give some discount on that toothpaste to that customer for making their customers happy. This is one of the examples. So big data is actually large set of data that is analyzed, okay, and you get the patterns and trends of the customers, and then finally you predict something useful out of it. So data is growing. You see, from bits, bytes, kilobytes, gigabytes, terabytes. So this range from terabytes to yottabytes you can consider is actually big data. Not gigabytes won't be called big data. So this range from terabytes to yottabytes is considered big data. So data is growing because of the social media usage. Every minute it's there is a means a prediction that approximately by 2020 there will be 40 zettabytes of data that will be generated. So huge amount of data is getting generated because of every minute you are using emails and likes, comments on Facebook, tweets. You're uploading photographs on Facebook. You're uploading videos on YouTube, like that. So data is the new oil, and companies are actually trying to extract it, refine it, and most importantly, it's trying to monetize it. So this big data is very important. You cannot say, oh, data is growing, let's not use it, you throw it away. No, it's not like that. You have to actually leverage the benefits of that data and get useful insights out of it for your business. Like I gave you example of toothpaste. So there, the trend of the pattern of the customer, that he's purchasing those products oftenly, that cannot be ignored. That is something very much useful for their business, to gaining insights from their businesses, right? So this big data is really valuable, for customers, for making them customers very happy. Like for Amazon, when you go to search for some products, say gaming mouse, it will recommend you, okay, you can buy these this and these products. You must be knowing. So it gives you personalized experience on that page of the recommendations, right? So this makes customers really happy. So there are other examples of recommendations. You're walking into gym, it will recommend you some workout music. Okay, people who have joined now, we're just going through basics of what is big data and Hadoop. Okay, but we'll be going through Spark after this. So I'm quickly walking through this. As Palasri or might be other people who might not be knowing what is big data and Hadoop. Another example is like location-based ads. So mobiles are everywhere. So real-time based location ads can be given using GPS. So now supposing there is a big bazaar, you are walking near big bazaar. Okay, you have mobile, you are walking near big bazaar. So quickly you get a message. Okay, we have some sale going on this product. Especially it will give you discount on the product you keep on buying from that shop market, right? So big bazaar needs to keep a lot of information. It needs to know your current location using GPS. It should know what recently you have purchased. It should know your profile information, your gender, or maybe your surfing habits, like that. So based on that, it will give you an advertisement, okay, we have a discount on this product. This is another example where big data is used, is because there will be a lot of data when you search. Supposing you want to search for some hotels on these sites like yatra.com and makemytrip.com. So you can get a huge list, right? You can get a huge list, but Will that be beneficial for you, useful for you? No, because searching again from thousands of hotels is so difficult. Which one should we go for? So what they do is, out of that huge amount of data, they'll analyze, okay, which are more popular among people. And so the result will be based on what other customers have chosen on that particular search. So you don't have to go through the huge list. So that makes customers really happy. Okay. So based on the customers' trends and behavior, they analyze and give some useful predictions that is beneficial for customers. So mostly, almost now, all startups, everybody is using big data. That's why it has become so important to learn this technology and get a good job in the market. And even if you're working, then also uh, you have to be up to date with these this hottest skill in the market, these technologies. So industries are using big data to transform their business models and improve performance in all the areas. Okay, I'll give you more those use cases I've already shown you where they are used. So generally when we talk about big data, we think, okay, it's huge amount of data volume, it's there. But it's not just about volume, it's about other concepts. We say 4 V's, or most popularly we call 3 V's of big data: volume, velocity, and variety. So till now you must have seen that in variety, when we talk about, we have seen structured data in like relational databases. The database, we have rows and columns, that is structured data. But with the Hadoop world, you can have different type now, because you're using these wearable devices, sensor data. So data will not be in a structured manner. You are uploading videos, images, tweets. So they are not structured. You can think they do not have a definite structure like rows and columns, right? So you need to actually here you need to there is a challenge in front of you, that you have different forms of data and different varieties, that could be images, tweets, or videos, or sensor data. So how to analyze them and work with them. Then the velocity, the speed at which data is entering into your system, is also one of the challenges. Volume is a challenge, because how to store the data, that is fine, we already talked about. Okay, we should not throw that data, we need to keep that data. That data is valuable. So another V we talked about is variety. So third V is velocity. So velocity, so example, like I give you, supposing you are searching Amazon site, and then uh, you're searching for a gaming mouse, and at that point of time you get a mail from Amazon that we will offer a discount of this 10% to you on this product. So you'll be very happy and maybe quickly buy that product. So how they are able to uh, track that you are trying to purchase that product, and they have to reply you in real time. Do you understand the concept of real time? Real time meaning they have to reply you at that very moment. They cannot wait for tomorrow. Okay, we'll reply tomorrow. Maybe in that time, meanwhile, you'll go to Flipkart and buy a product, right? So for improving their business and making the customers happy, you have to actually analyze the data at that very point. You have to, okay, track this person is searching for this product, quickly mail them. So all that is a challenge. The rate at which data is entering into the system, you have to analyze it at that time only. Then veracity, you have uncertainty of data. The data is might not be of good quality. Maybe we're not going in detail of that. So volume of data can be machine generated from sensors or personal health trackers, human generated from social media or YouTube. Organizations might be generating the big data, credit card information, commercial transaction, and the medical records as well. So here I'm walking through very fast, because I'm doing it for people who don't know about it. So velocity, like I told you, variety, you see this is structured data in the form of Excel sheets, rows, column, that is structured. Unstructured is this type of data. So the solution to the problem is distributed system. Now you have huge amount of data. Distributed system means you will be using multiple machines for a single job. Now you won't be storing data on one machine. You'll be storing data on many machines maybe. Okay. So like suppose if I say data starts growing and you have 100 terabytes of hard disk here on one machine. So now your data you need to store is 200 terabytes. So you'll add more hard disk here, right? Again, your 100 terabytes more data is coming. You said, okay, I'll add more hard disk to this machine. So you are actually making it more expensive and also complex. So rather than adding 100 terabytes every time to the single machine, and we scale it, means we add more machines of 100 terabytes, whatever we require. So this is called distributed systems, where we use multiple machines for a single job. for a single job. Now, how does this distributed system look like? It looks like, it is a team, but it hasn't it doesn't have a captain. So, okay, it doesn't have a leader. So the problem with distributed systems is that, there can be a high chances of system failure. There'll be programming complexity. So the solution is Hadoop. So Hadoop comes as a framework which acts as a kind of leader which will manage if one node fails, what will happen. So in a distributed system, these are called nodes. Okay, these are called nodes, and this is called a cluster. So this is a cluster of, say, 5 nodes. So one node fails, other won't know in a distributed system. But Hadoop as a framework comes for the solution of this problem, okay, as a leader, means as a framework wherein if one system fails, the other will know. All these is taken care by Hadoop. And what if the data, one node fails, what about the data? So all that is taken care by Hadoop. How to store the data and how to process the data. That is what Hadoop does. So it does two things, storage of data and the processing of data. So what is Hadoop? It's a framework. It allows for distributed processing of large data store, a cluster of commodity computers. So those across different nodes, it can store the data and it can process them parallelly so that you get the output in faster manner. Okay, so not going in more detail. So Hadoop stack looks like something like this, where you have HDFS for storage, then you have MapReduce for processing. Then there were other components that had come up for Hive, Pig. Hope you know about these. Varun, people, do you know about these components of Hadoop ecosystem? Core Hadoop has HDFS and MapReduce. So we have, for storage, we have HDFS, and for processing, we have MapReduce. Okay, so people who have joined now, can you tell me, do you know Hadoop or not? Surya, Parlisha, Abhishek. We haven't yet started with Spark. People who have joined now, I want to tell you that we haven't yet started with Spark. So Surya, you don't know about Hadoop? Okay, so hope you had joined earlier. When did you join? Did you catch up with the class? We were talking about Bigdata and Hadoop. Okay, so a quick recap. What we talked about in Bigdata Hadoop is that I just told you what is big data. Okay, so I gave you example that if you go and purchase a toothpaste after every 2 months, so that shop market will track, okay, your patterns. These are the customer patterns, and it will predict something useful. Okay, these products are oftenly bought by the customer, so I should give them some discount, maybe, so they'll be my regular customers. For that, you need to actually store that data, right? The data will be keep on growing. There'll be so many customers. Then each company, they'll have their websites. You need to track which people are actually coming to your sites, or for marketing purpose, means you might be having Facebook page, companies having a Twitter account. So all these, from all those sources, it will get the data and try to analyze. Like, suppose one more example I can give you is uh, like this Big Bazaar only is having one center in Delhi, one in Calcutta maybe, and one in Bangalore. So now in Delhi, it analyzes the people's purchase and finds out in Delhi that people are more they are more interested in buying beauty products. So it will do advertisement according to that. It will advertise about the beauty products in Delhi. Then in Bangalore, maybe people are more concerned about health products, so it will advertise according to the health products. So how does it do that? It analyzes the customers' data, maybe through Facebook or tweets, that they are more interested in which type of products. Accordingly, it can market its products, right? Parlisha, you can't hear, is it? Everybody else is able to hear. You can actually join again and then see. Hope everybody else is able to hear me. Yes. So Parlisha, kindly join again. So then I told you how data is growing, and this big data is really valuable. So I've already told you how this big data is already valuable and it's used everywhere. So we have this 3 V's of big data. Mainly we talk about volume, variety, and velocity. Hope this much you people understood. I'm going a little fast. And the problem, these are the challenges we talked about: volume, velocity, and variety. So the solution to these challenges is, okay, let's have a distributed system. So people thought, let's distribute the data. Rather than, if one person cannot solve a problem, then what we do? We assign it to 2 people. When 2 people cannot perform a particular task, what we do? We assign it to 3 people. That's how we work in a team, right? So Similarly, they thought, okay, we'll do that. But the problem is that in distributed system, how each are going to coordinate among themselves. If one node fails, how other will know that it failed? So it looks like a team without a captain. So the solution to this problem came with Hadoop. Hadoop has come as a framework which will take care of all these things. And it will, with the help of Hadoop, you can store your data in distributed manner and process them parallelly using MapReduce. So this is the big data stack. Means that core Hadoop has store for storage HDFS. So HDFS is like, like you have file systems for Windows, Unix. Similarly, when you want to store data in distributed manner, you will have file system that is for distributed file system, but this is for Hadoop. So that's why it's called Hadoop distributed file system. That is HDFS. Then you have MapReduce. MapReduce, now you have stored the data. Supposing you have stored the data, and now that file is supposing a huge file, and that is stored on 3 nodes in a cluster. You have a cluster of 3 nodes, and you have stored your data file. You have divided. Okay, so you have a file, and it's a huge file, and suppose it's divided into you have 3 nodes, so you divide it into, the Hadoop will divide it into 3 parts. Okay, so there is a default size of how many, means like for Hadoop, that particular size of the block will be there. Okay, so accordingly it will be divided among blocks. So it's divided among 3 blocks. So one block will go on this node we say machines. One block will be stored on this node, and one block will be stored on this node. Okay, so this is how one file will be divided and stored into 3 nodes like that. Now supposing this data is stored now in this file, you want to do some processing. Say you want to count number of occurrences of word, means you have some words and you want to count them, how many times they have occurred. So you have written a Java code. Okay, you write a Java program, and in this you write the logic, okay, how to count the number of words. Now that is what processing is. So you bring this program to the data. Okay, you bring the program to the data, and then the processing will take place parallelly on these 3 nodes, and the result will be given, output will be given as the word count of how many words, number of occurrences of words are there. Got it? So this is called, that is done by MapReduce. Okay, the processing part is done by MapReduce, and the storage is in the HDFS. So Hadoop has 2 components, for storage HDFS and for processing MapReduce. Any questions till now? Did you get the concept of what is distributed system and what is Hadoop? Then you see in the big data stack, this is the one for processing of data. So whatever you do processing in MapReduce, that is you have to write Java code. Okay, so you should know Java for writing the MapReduce code. So that was a problem. Actually, that is a problem. Upon that, there are solutions that have come up in the form of Pig and Hive. So people who see, everybody doesn't know Java. The business users, the end users who want to analyze quickly, they use SQL, right? So they cannot, they don't know Java. So similarly, what happened in Facebook was Hive was developed by Facebook. So Hive was developed by Facebook because people there were more employees there, they knew more of SQL. So they didn't know more of Java. So this very similar to SQL. So Hive came out of desire of those people, and most of the data analysts, they are using now Hive as a very popular tool. So that is on top of MapReduce. So now people are not using that much MapReduce. People who are data analysts, they will popularly use Hive. Similarly, other components started coming up because of the complexity of the MapReduce programming, like Pig and Hive. These came. Okay. Then you see here Scoop and Flume. Anybody knows what is Scoop and Flume? Varun?
Ma'am, in Flume we goes data from SVFS to local and local to SVFS. And in Scope, I don't know, means, I forgot it.
Okay,
Something.
okay, no problem. So Scoop is a tool. Like now, supposing if you're working in a company, your data will be in relational databases. Okay, the traditional relational databases. Now data is growing. The most of the challenge what people face is, okay, now I cannot analyze the data because it's in relational database. We cannot scale it on different nodes. So they bring the data from relational databases like MySQL into the Hadoop world. Okay, so that getting of data from relational databases to Hadoop word is no, getting through Scoop. We can use Scoop tool to import the data from relational databases to Hadoop to HDFS. We can store here. And Flume is like it's a real time. You want to ingest something in real time. Say your tweets. There are many companies, they analyze their tweets also, right? So that signifies that how popular those things are there in that company. So they analyze their tweets for, and now tweets are real, they are getting generated in real time. Every second some tweets are getting generated maybe. So uh, how to get that data, tweets data? That Flume does that. Flume gets the data in real time. Getting my point? Scoop gets the data not in real time, it is already kept there in relational database. You can get it, and then later on also you can get more data. But Flume is something I want to analyze in real time, and I am ingesting the data quickly from Twitter and getting into my system. Okay, so coming to now Spark. So now, because whenever you, if you want to go for Hadoop course, you should go along with Spark only. It should not be separate Hadoop Big Data. It should be with Hadoop and Spark together, because Spark is very much important. Um, it's very much moving in the market, and in this webinar I'll show you like what are the job trends and how it's like going to be really good for you. Why should you learn Apache Spark? So first we'll see the history of software and hardware changes that has led to the development of Spark, and then we'll see why we should learn Apache Spark, what are the advantages, and we'll compare Spark with Hadoop. Also we'll see what are the new things that are coming up in Spark 2 new version. So till now, in till 2000, what was the state of hardware? So disk was cheap and it was a primary source of data. So till 2000, the all focus was in on disk, and this RAM was also costly, network was also costly. So all focus, most of the focus was on disk. It was a disk was used as the primary source of data. Okay, and till then there were only single core machines. Okay, even Intel, it was only increasing the processing of single core machine in gigahertz. It was increasing from 1.5 to like that, but it was still single core machines were there dominant till 2000. But now RAM is actually the most important thing, and RAM is the king. So now RAM is the primary source of data, and we use disk only for the fallback. Network has also become speedier. Now the difference is still earlier we were using single core machines. Now multi-core machines are the commonplace. So this is evolution. I'm showing you how the distributed systems have evolved because these of the changes in hardware. So now the hardware change, but there is if you do not without software there is nothing. So till 2000, software you mean by the language you was using. So what is object oriented? Everybody knows object oriented languages. Can you give me any example of object oriented language? Yes, Rahul, you're right, Java. So till 2000, object orientation was the king, and software was only optimized for single core because there were single core machines. There were no open frameworks for creating, means there were no frameworks. You had to do it on your own for distributing the data and doing the processing. And for analysis of data, SQL was the only way. So most popular were object-oriented languages, and for data analysis, SQL. That was there until 2000. But now functional programming is on the rise. That is important part that is coming up is functional programming. So functional programming is nothing new. It has always been there. The difference between object-oriented and functional programming we have talked about. People have already talked about that. Okay, we should use object-oriented or functional programming. But now functional programming is on the rise because of the multi-core machines. This functional programming is very much you can easily optimize for multi-core. So because we want to optimize for multiple cores, and this these we using functional programming, we need to scale over a period of time. So that's why functional programming is on the rise. Can you give an example of functional programming? Have you ever heard of functional programming language? No? So we'll be talking about Scala, that is a functional programming language. The other are like Haskell. So we'll be talking about in detail in the course that what functional programming is actually. But with the recent recent trends, no, functional programming is on rise. And the software now needs to exploit multiple cores. So now, because hardware is mainly having multi-core machines, so the software also needs to exploit multiple cores on single. And you have good frameworks to create distributed systems, like you have HDFS for storage, like I already told you, and then you have Apache Mesos or Yarn to create distributed processing. Now, another important difference is now something called NoSQL has come up. So anybody knows NoSQL? So NoSQL is very different from SQL. Like traditional databases, they do not scale out, right? You cannot scale out. Do you understand the meaning of scale out? Means you cannot distribute them on various different nodes. So now NoSQL database come up because we need to scale out our data on different distribute our data. So any example of NoSQL databases? HBase, Cassandra. Anybody heard about MongoDB? Okay, we will be talking in detail in the course that what are NoSQL database. Basically, I'm telling you that SQL, it's not only SQL. NoSQL means not only SQL, it's more than that. Like in SQL, you have to define your schema. In NoSQL, you do not have to define your schema. So basically, it's suitable for big data environment. You can think that NoSQL is suitable for big data environment. So now the big data processing needs. So earlier, no, big data was a luxury. Only till 2000, only few companies used to use big data for their processing, and there was mainly batch processing. Means there was huge amount of data. They were mainly for focusing on volume. And do you understand the difference between batch processing and real-time processing? So people have already learned Hadoop. They know that this is mainly focused on batch processing. So batch processing means data will be stored some period of time and then processed using Hadoop. Means there will be some time lag. There'll be some time lag. Supposing some data is stored on disk, then it can be processed later on also over a period of time. Like I told you the difference between, like I told you what is real time. So in real time, there should not be any time lag. So now, real time processing is so important. Supposing in credit card fraud detection, supposing you are doing some transaction here in India, and after 1 hour or so, bank is seeing that your card, you have transacted your card, you have done a transaction through your card in US. So that is a fraud, right? It needs to inform you in real time, right? It needs to inform at that point of time. If it informs you later, then that fraud would have occurred. So it needs to inform you in that real time. So that example of credit card fraud detection is what we call it's real time processing. So till 2000, only people are focusing more on batch processing, but now there is need of real-time processing, as important as batch processing. Okay, so for that, no, velocity is the concern. You need to analyze the data at very point. Like I gave you example of Amazon. People are buying product and you want to give them discount at that very moment. So that is real-time processing. So for that, you need to take care of the velocity, the rate at which data is entering into the system. So now the scenario is that every company is using big data, even all startups. Okay. So till now, till Hadoop is treated as second generation, we are moving to third generation with Spark. So what were the shortcomings still there? That batch processing was the primary objective, and it was not designed to change. Everything was map and reduce. Everything you have to write the code in map, reduce, and Java program. So that was not feasible. Okay, and it was becoming too much complex also. So came the third generation, that is that we call as Spark. So Spark is actually third and we are entered into third generation distributed system. So here Spark is getting very much popular because it can handle both batch processing and real-time processing. That is one of the things, and it exploits RAM as much as disks, which makes it really speedier than the MapReduce. MapReduce I'll talk about in detail, and it's multiple core aware that we want. We want our software to be multiple core aware because our hardware has become multiple core. We have now 4 cores, octa core, like that, and we do not want to reinvent the wheel. So Hadoop is already there. So Spark is like kind of replacing MapReduce. You can think of Spark coming in the ecosystem in place of MapReduce. So there you have HDFS for storage, and you have, the processing can be done using Spark rather than MapReduce. So you're not reinventing the wheel, means you're not entirely creating a new framework. The framework will be same, which has storage HDFS. Only the processing has changed because now I told you how it has evolved. Because now we need to handle both batch processing and real-time processing. We want to use RAM, we want to be multiple core aware. So till now, the community needs that everything should be there. Batch processing also we can do, interactive processing also, streaming also we can do. So we want to have all of them together. So what happened till now when you were working with Hadoop, I've already shown you that we have MapReduce as general batch processing. Then what came up on those systems was like, if I want to do graph analysis, then you could have multiple solutions getting evolved for like Apache Giraffe, Graph Labs. Okay, then suppose you want to do real-time streaming, then you have Storm. Okay, you want to do interactive processing, then you have Impala. So all these solutions try to come, because there were some limitations of MapReduce. Like everything has to be coded in map and reduce. Then people who don't know Java, it's complex for them. Means so different type of solutions started coming over. So there were specialized systems that came over it for interactive streaming and graph analysis on top of this general batch processing map. So now the solution, so the drawback with second generation was that there you had to get so many components you have to install and get all these components over MapReduce and then work in Hadoop. So it becomes really complex. So Apache Spark has come as a comprehensive solution for that. So now Hadoop stack. We already talked about. We have storage as HDFS, right? We have storage as HDFS. Then on top of this, MapReduce is there. But now instead of MapReduce, we are using Spark for analysis. So in Hadoop stack, you can think, okay, MapReduce is there for processing, and then Spark is there. So when we compare MapReduce and Spark, why Spark? Okay, we have already MapReduce and Spark, because we are moving to third generation in a way that our hardware is changing constantly. We need to actually speed up our systems. We want real-time processing. So MapReduce could do only batch processing. But now the scenario is that we want to do real-time processing also, right? So Spark is a distributed computing system, and it is for processing of data. So Hadoop is for storage as well as processing. Spark is for processing of data in distributed computing system. Okay, so that is the difference. One of the differences, unification of batch interactive streaming. So till now, it was MapReduce's batch processing only. If I want to do interactive or I want to do real time something, then I have to get other solutions. Like for other type of analysis, I have to get Hive, I have to get Pig, Impala, all these components you see, you have to get those components over it to work on it. But Spark actually combines them all. I'll show you later how it does. Then do you know the concept of cluster? Means resource management. You know what is yarn and mesos? Anybody? So let's leave that concept. Then you can process your data stored in various storage systems. Means like I told you, the storage will still be same, HDFS, and it supports multi-language APIs. So Spark is actually written in Scala language. And Scala language is a functional programming language. I gave you example of functional programming, Scala. So when we learn Spark, we are also going to learn Scala language, or it supports, though it is written in Scala, but it can support Scala, Java, Python, or R. So whichever language you're comfortable with, you can use with Spark out of these four. So the difference between this MapReduce and Spark is, this diagram will show you. So why is Spark faster than MapReduce? This diagram will give you the answer. So Spark does in-memory computation. What does in-memory computation mean? So till now, if you already people know MapReduce. So they already know that take the input, they read from HDFS, then they again write the output to HDFS. Again, they'll have to read from HDFS. So this all is what is stored on disk, right? So if you want to do, supposing iterative processing, okay, you want to iterate over data again and again, so this will be very slow, right? So people came to know that Hadoop is not suitable for machine learning kind of algorithm. If you know machine learning, you have to iterate over the data again and again. You have to do iterative algorithms like that. So in case of that, you have to read and write data over and over again to the disk, which makes it really slow. But in case of Spark, you do in-memory computation, means you store the intermediate data not in disk but in memory. Okay, so that makes it really faster. So you know that it's 100 times, Spark is 100 times faster in memory, and on disk also it's 10 times faster than traditional MapReduce. Okay, so with the help of Spark, you can store the intermediate results in memory, which makes it really faster. Okay, so this is in-memory computation with Spark. This is what you do with in Hadoop. So we talked about unification. Unification means everything you can do under one hood. Means batch processing, interactive streaming, okay, everything. So it's really good for developers and for users and for distributors. Okay, the developers, you can code in one platform and use it for anything. Okay, and it's for good for users. You can take your applications. It's not necessary you can run it on Hadoop or Mesos anywhere. And also, good for distributors. You can have more apps. So like Databricks, it doesn't have its own distribution. You know what distributions about? You know about Cloudera, Mapr, and Hortonworks. These are distributions, right? So it is good for distributors. So another advantage of unification is that it brings one abstraction. So, best part about any system is that if you have a single abstraction, you do not have to learn everything. So there is one layer of abstraction for everything called RDDs. So if you understand RDDs in Spark, you can do anything. You can do batch processing, you can do streaming, you can do interactive processing, anything you can do. You can do mix and match, different type of processing in your application. So I give you one example. Like supposing you want to do spam detection. You know what is spam detection? Like in email, when you have a Gmail, so there you can put some mails to spam folder, right? So, and some are automatically sent to spam folders, right? So how does Gmail do that? How does it know that these are spam mails and it will send to the spam folder? So there is that we learn detail in machine learning. So it uses machine learning algorithm. It finds out, like on the basis of keywords, like supposing you reported some mail as spam, which is saying, okay, you won a lottery. So you say, okay, this is spam, and the user has reported it as spam. So now Gmail learned, okay, if somewhere it's written, okay, you get a lottery of 1 lakh and like that, those mails should be reported as spam. So if another user will get similar kind of mail, it will it will push it into the spam folder and report it as spam automatically. So in this spam detection algorithm, like I give you example, if you use Spark, so what will happen is, like you get the input data, means in spam detection algorithms, they have to be done in real time, so it's streaming. So they are mostly, I told you, they are machine learning algorithms. So you create a model and then you pass it to streaming. So the problem in models is that you're not up to date with the new data. So in case of uh, Spark, what you can do is you can get the input data, stream it. Okay, so everything you here see RDD. RDD abstraction means if you know RDD, it will be flowing through all the things. You can do machine learning with it. Then you can do some querying on it using SQL. Then you can store it in the database. Okay, so the developers, they actually need to learn only one API, that is RDD. So you do not have to have different learning for MapReduce, and you have some developers for Hive, like we talked in big data ecosystem. So the same RDD acts as an abstraction layer, and there's one layer of abstraction, RDDs, which will be flowing through all these. So these boxes, they are not different processes. Like in case of Hadoop, you'll be having Hive as different processes, Impala as different processes. These are different API calls. Okay. So in case of Hadoop, like for streaming, you will get Storm. If you know Storm, you'll get the real-time data. Then you will write it to HDFS. Then you do MapReduce programming. Then you put it in HDFS. Then you use Hive and do SQL type of querying. Then you put it in HDFS. Like that, you have to use so many systems. Means there will be 4 systems. We'll be talking different abstractions. They'll be having different processes, different abstractions. But here you have a common abstraction that is called RDD. So having different processes, different systems, that also makes your the system very costly. Okay, there will be so many conversions that will be required, convert one form to another. But in case of Spark, you have one common abstraction. There will be no conversions needed. Okay, so Spark is its 3rd generation because of this unification. So because of the unification, you have common abstraction, and you do not have to have different systems to perform different things. Like in case of Hadoop ecosystem, I told you, for different processing, type of processing, for SQL processing, you need Hive. For interactive processing, you need Impala. For streaming kind of job, you need Storm. So you have to have different processes there, different systems there. But in case of Spark, you need not have different systems. So if you compare, there we were using Hive Impala, here we have Spark SQL. There we have Mahout for machine learning, now it's moved to Spark machine learning library. There we have Apache Storm we were using, now we are using Spark streaming. So here these are not different systems. There in Hadoop ecosystem, they are different systems. We have to install, and it will be taking different systems, installing them. It's a real challenge, and very making the things complex. But in Spark, you have these are different API calls or different libraries that are there in Spark, and they share the common abstraction RDDs. There I told you for graph analysis we have Apache Giraffe. Here we already have the libraries provided by Spark. Okay, so case study is like people are one of the companies like Trovit. It was using MapReduce, then it jumped to Apache Spark. Why? So a little bit about Trovit company. It's a classified ad engine, and it was using HDFS to store the data. Okay, because it has huge amount of data, so it said, okay, I'll store the data in HDFS. But the problem is when they were using MapReduce, they were there were a lot of disk activities. Like I told you, it was making the things very slow, and also the MapReduce programming was making things very complex. So they found a solution, Apache Spark. So it is a fast distributed processing framework. It's 100 times faster than MapReduce, and instead of running their code on MapReduce, they started using Spark, and they noticed very high speed, means the performance improved a lot. And also they found that there are a lot of libraries that Spark offers, and they can do a lot of processing. They can do good analytics, means the data analysis through Spark SQL. They can do machine learning through machine learning libraries. They can do graph analysis using GraphX libraries in Spark. So Facebook also, I told you that Facebook already they had developed Hive, but even they have started using Apache Spark. They compared that, Hive. If you compare to Hive and Spark jobs, they'll be there. You see, latency have low latency is better, means they'll be more faster. So they found that Spark is running much faster than their using Hive. So even Facebook has started using Spark. So now you can use Scala or Python. So if you are comfortable with any of the languages, you can actually work with it. So we're not going in detail of these. People who already know Scala and Python, let me know. Anybody knows Scala or Python? Then I'll compare. Otherwise, no use. Little bit knowledge about anything Scala or Python. Anybody heard of? So basically, one difference I'll tell you when to use Scala and when to use Python. See, Spark is written in Scala. So people prefer, so for basically for model creation, development process and all, you use Scala. Python is basically used by data scientists. So Python is good choice when you're doing smaller ad hoc experiments like data scientists, and Scala is good when you're working on bigger projects in production. So that time you'll be using Scala. So you see that Apache Spark is quite popular, which the people are using Apache Spark. And job vacancy trends also, if you see, compare from 2014, it has drastically increased. So we have a lot of job vacancies coming up with Apache Spark. So this is the newer version of Spark 2. So in this course I'll be even telling you about the latest version that is had in the industry, as Spark 2. So this shows the stack, like we have the Spark core, then we have RDDs here, the basic abstraction, and these libraries: Spark SQL, Spark Streaming, Spark R, Machine Learning, GraphX. And in detail, we'll be talking about in the course, but these are the libraries which are coming with the Spark. So the course details are that we'll be talking about the Scala language fundamentals, we'll be talking about the Spark core APIs, Spark SQL, what is Spark Streaming, and machine learning libraries of Spark, graph libraries of Spark, and we'll be doing some real world projects and assignments. Any questions? So now, did you understand advantages of Spark over MapReduce? It's much faster than MapReduce, right? You need not learn so many systems. You need to just know about RDDs. If the developer know RDDs, they can work on anything, machine learning, Spark SQL, anything, right? And Apache Spark is good for machine learning because it does in-memory computation. That's why it's also faster than 100 times faster than MapReduce. Got it? Now open the session for questions. Yes, people, please come up with the questions. No questions? Yes, Rahul. I wanted to know about you. Can you give your introduction about yourself, Rahul?
Hello.
Yes, Rahul. Please introduce yourself.
Ma'am, currently I'm working as a deputy manager for an FMCG company. But
Mhm.
earlier, I worked for airlines domain and banking domain in my previous work with TCS, where I was working in C and Unix programming. So after
Mhm.
that, after having some managerial experience, I am into business analytics, learning it from Ivy School of Learning, and then I came across this session for learning this Scala and Spark.
Okay. So you have already gone through Hadoop course?
No, I am going currently learning R from Ivy
Ah,
School.
okay. Okay, so did you understand about Apache Spark, how it has come in the third generation, and how it's eliminating the drawbacks of the second generation systems?
Yes, actually, in my previous project, I worked for airline domain, United Airlines and Citibank. Earlier, where we used to learn do long-term forecasting and short-term forecasting, where we had some batch processing jobs, which used to run in the back end, and we used to do like seat assignment and all for the airline company. So there, I understood like how it has moved on from the batch processing time or a code which is stored in the server then to a real time scenario where we are processing data in the real time and all. So somewhat idea I got it now.
Oh, that's great. Anybody else? Samik? Any question? Surya Darshan? Varun? Nobody? Okay, then I should ask question. Why is Spark faster than MapReduce? Quickly on the chat box, you people can answer. Why is Spark faster than MapReduce?
As you mentioned during the session, it is just because the processing happening in the memory in the real time in case of Spark, as it was not in the case of MapReduce.
Yes, yes, you're right. Yeah, I wanted others also to interact, so I was asking them because they are not asking question also and not replying. Others, do you agree with the answer? Okay, thanks for confirming because I want my I like my sessions to be really interactive. Though we could not have a good interactive session, people are not replying that much, but still okay. A few of you still replied, and that I hope you liked the session and found it interesting to learn Spark. Had maybe your curiosity increase about learning it more in depth about what this Spark is all about and learning the libraries of like machine learning and the streaming Spark SQL. In the course, we'll be talking in detail about all of them. Okay, so that's all about the session. Any questions? Then we can take up. Okay, thanks Rahul for confirming. It was something fruitful for you. Okay, then we can wind up with the session. Thanks all for joining today.
Thank you, everyone from Ivy. I hope this training was useful and gave information. Thank you so much, ma'am. Thank you for such an insightful webinar. I think everyone has started. Thank you so much.